Okay, there I am. My name is Warrick Harvey, for those of you who don't know, and I am one of the strategic account managers at Modena. I am quite excited about today's session. There we are. And, you know, today's focus is on how do we BIM in Africa. And I want to take the approach from a very practical perspective. You know, BIM is not just a software conversation. It used to be, but I don't think it is anymore. BIM is more around risk identification and how do we optimize the use of BIM to identify risks early on the project so we can start benefiting from the return on investments that we promise everyone. First, I'll start with the idea that construction has been complex. Then we'll move through 3 delivery shifts, 3 eras, focusing more on how construction worked in the 80s, the transition into the 2000s, the introduction of the digital era, and how we manage projects using BIM in the 20s. 20s is 2020s, guys, and the 1900s have got. Then we'll bring it back to Africa and understand how the commercial impacts can benefit and destroy projects locally. And then we will do a quick quiz. I'll ask you to get your phones out, scan the QR code. There are 5 questions, but the focus there would be for you to identify where you are on your BIM journey and how we can optimize the risk identification. Are we all on the same page? Okay. Guys, if there are questions, raise your hands. Happy to discuss during the presentation. I don't want you to sit and be spoken to. I am hoping for a bit of an interactive session. If we look at large historical projects, pyramids, everyone's familiar with it, right? The guys who built the pyramids still had the same problems that we have today in construction. Materials had to be procured. They had to be delivered. We had to source labor. There was some budget. I don't know what the budget was. And there was a time constraint. Oh, on the same page. Has construction changed? No. It's the same thing. We're just doing it differently. We're building different things. What has changed is the introduction of BIM, the need for information. You know, projects nowadays involve QSs, project managers, health and safety, clients, project data handover. Jay was mentioning now, what happens to a Revit file post-project completion? It's stored somewhere, it gets deleted, and never gets used. So the need for the use of information today is a lot higher than it was 4,000 years ago, but the construction process hasn't changed. Let's look at the 80s. I firmly believe that this was the most hardcore generation in the construction era. They didn't have the tools, they didn't have the resources and the information that we have today, yet they still managed to finish their projects on time, mostly, within budget, mostly. Drawing off information at the back of a cigarette packet. They didn't have iPads, they didn't have Revit models, they didn't have fancy tools and technology, yet they still managed to do their jobs successfully. But I do want to frame that the flow of information was very analog. Me and you, sir, would sit down, we would discuss, okay, we've got a project, we need to build a thing, we designed it on pen and paper, we have an architectural firm that has 14 architects drawing it manually. Mistakes that happen, a lot more than they happen today, because there was manual work being done. And what happened when there was a change on site? There was a revision. Someone had to change a drawing. Had to go back to the architectural office, some guy to stand on a ladder because the drawings were like 1,000 feet wide. And that process of change still happened, but because it was analog, it happened a lot slower than what we used to today. Do you guys agree? So again, I'm going to keep hampering on the fact that construction process hasn't changed, just the access to information when it's readily needed has changed. Okay. Then the 2000s, the Gen X's, Gen Y's, I don't know. I'm part of this era. The introduction of primary CAD, AutoCAD, emails, PDFs. We threw the pigeons away, we stopped communicating via smoke signals, and we started emailing everything. But now the problem still remained that we had the introduction of digital processing technology, but we refused to change the way in which we received information, right? So in the 80s, someone would make a mistake and we would have a collapse and that process would go through its life cycle. That never happened in the 2000s. All that happened was we were able to email the wrong PDF to 20 people instantaneously. I know Jay mentioned earlier something about Excel spreadsheets. Who here uses Excel spreadsheets that are 5 years updated? You are in this era. You are still in the 2000s. The problem here was that the increased demand of information destroyed the ability for us to process the information correctly because time pressures were what us. Okay? There we are. Here's another case study. Wembley Stadium in the UK. Anyone familiar with the project? Mr. York. So, okay, 3 people in the room. Again, I'm going to read off my tablet. I don't want to get it wrong. The project had digital information, but digital information did not automatically create control. Okay? The stadium was a very technically complex project, especially with the geometry and roof structure and the major steel work required. Cleveland Bridge contractor was appointed by the client called Multiplex to complete the steel work on the Stadium Bowl project. But halfway through the project, the relationship between Cleveland Bridge and Multiplex, the main contractor, broke down. Multiplex threw Cleveland Bridge off the project. They cancelled their contract, and it was awarded to another company called Hollander to continue the work. Cleveland Bridge later walked away from its remaining fabrication contract, and from then the dispute escalated. Both parties, client and contractor, blamed one another for delays, extra costs, poor workmanship, missing or incorrect steelwork, paintwork problems, poor record keeping. So it was not a technical coordination issue anymore. It had become a delivery responsibility and commercial dispute. The issue was that there was not enough information. There was plenty of information. The issue was that the files did not create enough shared certainty around what was coordinated, who was responsible, what was approved, and what risks still remain unresolved. I started my career as a concrete core drilling person. I made holes in concrete, and there were 15,000 calls that weren't paid for. And we had to go through this process of proving to Wilson Bailey Homes that those holes existed. But the problem was those holes were filled with services. There was pipes and HVAC units and everything running through the holes. So it was very difficult for us as a company to prove that that work was done, because how do I undrill a hole, right? We did rely quite heavily on site instructions that were manual. But manual paperwork tends to get lost because in construction, your office is where? So your bucky, right? And if we had the tools that we have today, the fancy iPads and the BIM software and the BIM processes, a lot of that information could have been recorded digitally, could have been verified before we did the work, it could have been approved before we did the work, so that litigation process, so that you can verify those, is not so difficult to manage. All right. Now we're in the 20s, the 2020s, not the 1920s, guys. Are we still all awake? Yes. Clients want more certainty. Are we all in agreement? Right? Programs are tighter, margins are thinner, procurement is happening earlier, and teams are expected to coordinate more information faster with few surprises. Am I dreaming, or is that the reality of today's project environment? Yes? This is where BIM becomes extremely relevant. You know, BIM is not, okay, wait. Who thinks BIM is a nice 3D thing to look at? No one. Man, you. Is that all BIM is? And I'm not picking on you, it's just a question. Do you think BIM, the net result of BIM, is to have a 3D model that looks pretty? Okay. Sir? No. What BIM actually does, it allows us to take geometry, the Revit model, and link it up with the information. And once we connect both of those, that's where I firmly believe BIM offers value back to the industry. Because it's pointless having a look at a 35-story hotel, and when I click on a wall, there's actually zero information in it. So you're a masonry expert, you need to build this wall. You click on that, there's no information. What do? You go back to the 2000s or the 1980s era workflows, pick up the phone and say, hey, you know, what do I need to do? How do I need to do it? And I think it's crazy. You know, a clash found indoor Revit model is still a clash, it's still a problem. But what happens now is it allows us to fix that problem while we're still in the design phase. I don't know if you guys had been to most of our talks last year. One of the things I spoke about, failing in Pixel is a lot cheaper than failing in person, right? Who here currently uses clash detection and coordination in their day-to-day workflows? This is the construction show, guys. Okay, the four of you. So, have you found any benefit in doing clash detection coordination before that work goes to site? Yes. Have you experienced positive return on investments from rework, not happily?
Yes.
Okay, who else had their hands up? So, same questions. Positive, negative experience? Positive. We had one more hand up. No, there was 3 of you. You two. What's your experience? Would you be comfortable doing the projects today, looking at the 1980s workflow? No, right? So there is some proactivity in the industry where people are realizing that BIM is not just a 3D pretty model, but it actually has a huge amount of information that we can benefit from. You know, BIM does not make projects risk-free, and those of you who think it does are crazy. Risk is always going to be in construction. And the next slide, after the case study, looks at how BIM has not removed risk, but how it's pushed that risk upstream. Right, and we'll get back to that. So, here's our 2020s case study, and it has to end on a good one, right? So, again, reading from the iPad, the Grange University Hospital is a positive case study. The hospital that was finished in 2020, it is based in Wales. The model supported coordination, design for manufacture and assembly, sequencing, and off-site manufacturing. The digital information was not just there to look impressive, ma'am, but it did help the project team decide what could be manufactured off-site, how elements would fit together, and how the building would be assembled on-site. So it was a bit of a Lego. Who's here familiar with Modena and Before West Mall project? Similar process. They did a whole bunch of concrete casting off-site and they built the thing like a Lego project. When labor, material, and program decisions are made earlier using better information, risk is not left waiting for the guys on site to figure it out. The reports came out, and this was WSP and ACOM. They were the main consultants on this project. I'm happy to share the data with you guys afterwards. But they reported they finished this project 4 months before, 4 months earlier. They saved 23% on the program and more than 230,000 labor hours on site. Right? It's scary numbers. So, yes, that's design for manufacture and assembly. So it was just a process when they said, guys, we're going to design and manufacture off-site so that when we deliver those, does this point to work? Yes. So I'm not too familiar with the in and outs of this project, but let's just assume that that concrete facade panel was cast off-site. It was most likely delivered on-site, lifted up with a crane and placed, versus a traditional process of building scaffolding, putting the formwork, putting the rebar, placing the concrete, right? A very, very, very cool project. And they managed to figure this out through running iterations on Revit. They were able to figure this out without the building collapsing because they used tools like Robot. And this is not a sales pitch on product. Robot could have been used where they could have understood the failure point of has the city global net wall and designed against it. The results speak for themselves. 240,000 hours saved on site. The comparison whether risk was found early enough to manage or late enough to become a cost, delay, or a dispute was not in question here. The guy has won. And this is actually this is my favorite song for my presentation, and I hope that he's homework everyone today. So, project phases, forgive me if I got this wrong, start with a concept. They go to a design phase. There's a bit of a coordination process that happens. There's procurement. They need to build the thing, and the guy who pays for it needs to receive it. This process hasn't changed in the last 4,000 years, right? So it's a bit silly to say that the introduction of BIM and CAD and Revit and these tools and processes change that. What has happened is the identification of risks have been pushed upstream. So in the 80s, typically, risks were only discovered on site. Hey guys, we've got a problem, this thing doesn't fit. Okay, let's go fix it. But the 80s allowed for that. There was a contingency in the budget for that rework. That contingency doesn't exist today. But yet we are expecting our project teams to deliver work in the 2020s using 1980 error methods. We are wanting a digital environment, but giving our guys analog tools to do the work. Then the 2000s happened with the introduction of emails and CAD and cell phones and all of those good things, and risks still did not disappear. What happened? They pushed upstream. Those risks will be identified in the procurement stage, and changes could happen before they reach sites. So this would have been expensive, that would have been less expensive, but still a cost because some procurement changes needed to happen, but at least we didn't build it and fix the problem on site. Right? We could have called the tile and say, oh, wrong color, please, get pink, not blue. But what is exciting is the BIM era of the 2020s, where we can now start identifying risks in the design phase. Our 3 or 4 hands that use BIM collaboration and clash detection, this is where those risks are being identified and changes being made. It gives you the opportunity to challenge the team, fix the problems, coordinate them properly, so by the time we're building whatever it is that the client has paid for, there's no additional costs on rework. There's no additional claims. The programs are within budget. We saw the previous slide. Those guys finished 4 months early. 240,000 hours saved. Because they benefited from the risk identification much earlier on in project lifecycle. Questions?
No. Oh, this thing is blinding me.
So once a coordination issue reaches site, it's no longer a technical problem. It becomes standing time, rework, procurement, disruption, program pressure, and margin loss. Who here experienced that at some point in their life? I remember I was sent to Liberia. It was actually a really horrible project. We had to identify problems in the northern part of the country in Tokatia, 600 kilometers down the railway down to Fukanda. Okay? We got to site, and the railway didn't exist. On paper, somebody was paid for it, but when we got there, the thing didn't exist. Somebody was paid for work. The Ebola outbreak caused a lot of problems there. But if we had access to the information earlier, we wouldn't have needed to spend 9 months in country trying to figure out problems. Okay, so projects start bleeding commercially the later the risk is identified, right? And this is quite an important slide here. Today's margins are no longer protected by yesterday's workflows. Like I mentioned earlier, we're expecting 2020 delivery, but giving our guys analog tools to do the work. And it's so scary. I do not believe our BIM challenge is only software related. I don't believe. BIM nowadays, I'm not going to talk about product, is accessible to everyone. At a reach you can swipe a credit card and have access to some sort of software. The tools are there. The skills, you are increasing in numbers. Companies are offering training courses, YouTube has training courses, so the people are there, the tools are there, the skills improving. The biggest issue is the reliability of the information being produced. So how are we creating that information? And how is it being sent? How is it being received? On any project, not only in South Africa but globally, we have quite a number of contributors, QSs, project managers, clients, health and safety. And contractors will always check the coordination. QSs will always check the budget. Clients will always check the report. The problem starts when the shared information is not trusted and not reliable enough to be the starting point for the project. That's when contractors have their own program that's not project aligned. Clients have their own reports. QSs have their own Excel spreadsheets. And all we've done is we've just made fragmented data, fragmented communication a lot easier through the use of BIM technology. Does everyone agree? So at that point, we haven't really solved anything. We've just made the processing of incorrect information and confusion a lot faster and a lot more efficient. So the problem starts with shared information is not being trusted because we don't have the capacity or skills to create it. So when we talk about how do we BIM in Africa, I think it's a starting point, and the question needs to be not how do we BIM in Africa, but how do we make information reliable enough that teams can check it, challenge it, and then actually use it to make better decisions. If BIM is going to matter, we have to change our behavior. And that's not just locally, it's globally. First, we have to define what the model must answer. If the model was never briefed for quantity, sequencing, procurement, or handover, there's no way you can expect to give you that information after the fact. Secondly, we need to review risks, not just visuals. Pretty models do not protect projects, closed issues do. Thirdly, we need to assign and close issues properly. A clash report does not reduce risk unless someone owns an action, issues it out, and closes it responsibly. Fourthly, we need to connect both cost, program, and procurement. If unresolved design risks affect money, time, or packages, it needs to be commercially visible. Okay? And finally, price remaining uncertainty. And finally, price remaining uncertainty. That sounds horrible. BIM does not remove all risk, but it should help us know what risk remains, who owns it, and what the cost would be should it be realized besides.